It gives this block 1 an acceleration of the same a. Well, block 1 is 2, the mass. Right? So we know P from the question is 6 Newton. So we can calculate A equal to 0.6 from this. Okay? And then we put everything into this equation. P is 6. We don't know the force from block 2 to block 1. We know A is 0.6. So 6. If you solve this equation, you got the force is 4.8 Newton.
Okay.
The only thing is, remember all of them share the same acceleration. So these two are similar kind of questions. Number 12, 8 kilogram object rests on the floor of an elevator, which is accelerating downward. So acceleration is 1.3. The question is asking you what's the magnitude of the force the object exerts on the floor. So it's the same as asking you what's the force of the floor acting on the object, right? So the support and the gravity we know is accelerating downward. So equal to MA, right? And if you put everything there, A times, let's say that's 10, equal to 8, 1.3, equal to 80. So it's around 69. The question is 68. D, the answer.
Does it matter the arrangement you put mg minus Fn because you have rolled it F minus mg because mg is going down?
Yeah, because we know the movement is this direction.
So the mg would be negative, right?
The movement is this direction. So we know mg should be bigger, greater than F. Right? Because the total force is like this. It depends on the acceleration, which way you consider is a positive. So if you think here is positive, the acceleration will be positive. And the mg will be positive, but this F will be negative. Right?
Yeah, that's what I'm asking. Does it matter?
Yeah, of course.
Does it matter which way do we?
For example, they said if they say the acceleration is upward, 1.3, is upward. Of course, we will calculate differently.
The acceleration would be perpendicular to the gravity.
So there are
The acceleration will go in the same direction
as the force, as the total force.
Okay.
So here we know A is downward. right? Here the total force is downward, which means mg is greater than F.
Right.
So if you take positive, here is positive, here is positive, you can calculate.
Okay.
If you, for example, if you put F minus mg, that in that case, the object is moving upward.
So would the answer be wrong if I wrote it in that case?
It will be wrong.
It would. Okay.
Yeah. So you need to know what's the direction
Right.
of the movement. It's the same as the total force.
Okay.
The total force, if it's point down, it will move downward, accelerating.
Okay.
So that's this question. So even if you add those connecting strings and everything, it's the same thing. They share the same acceleration. It's actually the same. Okay. So in this case, we first look at this object. Okay, 2m. And on the string, suppose there is a tension T. The question is asking what's the tension in the string connecting this. The question is asking this T. Okay. So if you look at this object, it has gravity. It has a tension, right? And we know the force is pulling like this, so it's moving upward. And the total force is T minus mg, right? That's the total force for this object, equal to ma. And then you look at this object, 2m, it has a force, F, and then also the tension,
Right.
but in a different direction.
Right.
And then it's 2ma, because it's 2m, the mass. So the same thing, they share the same A. According to these, because we know F is 40, and the mass is 1.5 kilogram. So, and we are trying to solve this. T. Let's put this 10. Is 1.5. Okay.
Right.
And from this we know F is 40. M is 1.5, so 2m is 3. So we got these two. And you can solve those equations. One way is solve the A first.